Before code ran on silicon, builders had already learned to coordinate knowledge across time. In the early 12th century, across northern France, a new architecture began to transform stone, light, and space. It would later be called Gothic. It rose from older Romanesque traditions, yet it pushed them in a new direction. Pointed arches, ribbed vaults, buttresses, and great windows made interiors feel taller, brighter, and more open. The cathedral seems, at first, like a single impossible object, a structure so large that no individual could fully hold it in mind, and so slow to build that many of its makers would never see it finished. Chartres, Reims, Amiens, Cologne, and Notre Dame de Paris each tell a different story. But together, they ask a question that still matters today. How can many people, working across time, create something none of them could make alone? It is tempting to call the Gothic Cathedral the first decentralized network. That phrase is not literally true. Medieval builders did not have a network in the digital sense, and their projects had leaders, institutions, budgets, and plans. But as a modern comparison, it reveals something important. A cathedral was not merely a building. It was a system for coordinating knowledge, labor, materials, belief, and ambition across decades, and sometimes across generations. The first correction to the network metaphor is simple. Cathedrals were not built without authority. Cathedral chapters, the senior clergy attached to a cathedral, often led and financed construction. Bishops, monarchs, urban elites, religious communities, and donors could all shape authority. Money came through endowments, collections, gifts, rents, pilgrimage, relics, and many other local arrangements. At the building site, the master mason was not a modern architect, but neither was he simply another worker. A master mason could combine the roles of designer, builder, engineer, manager, and craft specialist. Under him worked a changing body of skilled and unskilled labor: quarrymen, stonecutters, masons, carpenters, plasterers, metalsmiths, glaziers, carriers, and many others. This was collective creation, but it was not leaderless creation. It depended on coordination. Stone had to be quarried, cut, transported, and set. Timber had to be selected and raised. Mortar had to be made in the right season. Glass had to be designed, produced, painted, fired, and installed. Accounts had to be kept. Wages had to be paid. Medieval construction records make one point especially clear. Most ordinary laborers were paid. Faith mattered. So did professional pride, local prestige, the status of relics, civic competition, wages, and the sheer difficulty of the work. A cathedral could be a house of worship, a financial project, a work site, an image of a city, and a stage for political authority, all at once. The work was also vulnerable. A shortage of money could halt a campaign. A change in leadership could redirect it. A fire, a collapse, a war, or a new liturgical demand could alter a design. Long construction was not evidence that no one was in charge. It was evidence that responsibility had to be renewed, repeatedly, by people who inherited a project already older than their own careers. Another myth has to fall away. Gothic cathedrals were not built without drawings. They did not use modern, standardized blueprints, but medieval workshops relied on design tools of their own. Surviving Gothic drawings include elevations, floor plans, sections, vaulting plans, tracery studies, and assembly drawings. Some are large and precise enough to guide complex work on a building site. Geometry was essential. Builders used proportion, measurement, projection, and practical calculation to turn an idea into stone. Knowledge did not live on parchment alone. It also lived in the hands of people, in apprenticeship, in repeated gestures, in tools, in templates, in rules of thumb, and in the experience of watching a wall rise or a vault settle. That is why the cathedral was both planned and adaptive. A project could begin with an overall intention, then change as money ran short, patrons changed, styles shifted, disasters intervened, or a new master mason took charge. Later generations sometimes altered towers, facades, vaults, chapels, or windows. The building was not improvised from nothing. It was revised within constraints. Here, the modern metaphor becomes useful again. Complex systems do not always need a single fixed instruction covering every future decision. They can combine standards with adaptation. Gothic builders had geometric practices, material constraints, institutional authority, and local knowledge. Those shared frameworks made change possible without making the project meaningless. Cathedral knowledge also moved. Master masons, stonecutters, carpenters, glaziers, sculptors, and apprentices traveled between sites. Workshops carried habits of drawing, carving, measuring, and organizing labor. Styles crossed borders, then changed in response to local stone, climate, money, patrons, liturgy, and taste. This was not one seamless European protocol. A cathedral in northern France did not simply send an instruction file to England, Germany, or Italy. Knowledge traveled slowly and unevenly. It changed as people translated it into new conditions. A form that worked in one quarry might demand adjustment in another. A vaulting solution could be admired, copied, simplified, or reinvented. The network was made of bodies, roads, rivers, contracts, workshops, apprenticeship, tools, drawings, and materials. A cathedral was never only an engineering problem. It was also an argument about what a community valued. Its spaces ordered movement. Its images taught stories. Its bells marked time. Its relics drew pilgrims. Its chapels remembered families. Its towers announced a city's presence from far beyond its walls. This is why a simple phrase, such as "every stone was a prayer," is both moving and incomplete. For some participants, building was indeed an act of devotion. For others, it was paid work, skilled craft, local status, or a source of income. Often, it was several of these things at once. The durability of cathedral projects depended on precisely that mixture: religious purpose joined to institutional finance, practical expertise, material supply, and civic ambition. The stained glass window offers a small example. It was a devotional image, but also an expensive technical achievement. It required glassmakers, painters, designers, metalworkers, donors, transport, kilns, and careful installation. Its light could be read spiritually, but its making was social and material. The cathedral's unity did not come from a single mind forcing every person into place, nor did it arise from unstructured spontaneity. It came from a demanding alignment of roles, each limited, each necessary, and each connected to a larger purpose. Now we can return to the language of networks, but with more care. In computer science, a distributed system divides work across connected parts. In social history, collective intelligence describes what groups can achieve when knowledge is shared, corrected, and coordinated. A Gothic cathedral was not a computer, and medieval builders did not think in these terms, but the comparison can still sharpen our view. No single person knew every task. A mason did not make all the glass. A glazier did not manage all the quarrying. A donor did not calculate every vault. The project worked because expertise was divided, linked, and coordinated. Information moved through drawings, demonstrations, contracts, tools, spoken instruction, and repeated practice. This is close to what the Greeks called techne, skilled making, practical knowledge, a way of bringing something into form. And it also invites the word poiesis, bringing forth, creation, the emergence of something that did not previously exist. These words should not become slogans. They name a tension we can see on the site itself. Rules mattered, so did imagination. Standards mattered, so did judgment. The lesson for the present is not that a cathedral predicted artificial intelligence. The lesson is that powerful systems depend on more than tools. They depend on the ways people organize attention, responsibility, learning, correction, and trust. In the 20th century, The philosopher Martin Heidegger asked a different question about technology. His concern was not simply that machines might become powerful. He worried that modern technological thinking could narrow our vision, that we might come to see forests, rivers, objects, and even people chiefly as resources to be ordered, measured, stored, and used. He called this tendency Gestell, often translated as enframing. It is not a synonym for a machine. It is a way of seeing. The danger is that calculation becomes the only form of understanding we recognize. The cathedral does not solve that danger, and it should not be turned into a medieval answer to modern technology. But it offers a reminder. Technical order and human meaning are not the same thing. A structure can be carefully measured without exhausting its significance. A system can coordinate many tasks without explaining why people chose to build it, or for whom. When we discuss AI, we need both questions. How does the system work, and what kind of human world does it help to reveal, organize, or conceal? Cathedral knowledge could travel, but it remained embodied. It lived in trained hands, costly materials, local workshops, and difficult sites. A design might be copied, a master mason might move, an apprentice might learn. But the reproduction of knowledge was slow, expensive, and never exact. The next transformation would concern not stone, but text. Long before Johannes Gutenberg, people had copied manuscripts by hand. Woodblock printing also existed in Europe before his press, and printing traditions, including movable type, had developed earlier in East Asia. Gutenberg did not invent the alphabet, printing everywhere, or reproducibility itself. His achievement was different and enormous. In mid-15th century Mainz, Gutenberg helped establish a highly effective European system of uniform, interchangeable metal types, oil-based ink, and mechanical presswork. The Gutenberg Bible, completed probably late in 1455, became the first great book printed in Western Europe from movable metal type. This changed the economics of copying. A manuscript could still be beautiful, rare, and laborious, but a printed page could be composed from reusable metal sorts, pressed many times, taken apart, and composed again. The crucial idea was not that language had suddenly been broken into atoms. Alphabetic writing had existed for millennia. The innovation was the standardization of reusable physical pieces within a coordinated production process. There is a meaningful comparison with cathedral building, but only a comparison. Both worlds depended on skilled labor, specialized tools, templates, standards, and coordination. Yet the press made one kind of knowledge more portable and more repeatable at a new European scale. It accelerated a print culture that would reshape scholarship, religion, administration, and public debate. The Gothic Cathedral was not a leaderless network, and it was not an early computer. It was something stranger and more human, a durable system in which institutions, craft, faith, finance, drawing, material, and memory had to work together. Its lesson is not that technology replaces people. It is that technology has always depended on forms of cooperation. Every complex tool carries an invisible architecture of training, trust, standards, responsibility, and shared purpose. From the cathedral site to the print shop, the story changes scale. Knowledge becomes easier to copy. Ideas begin to travel faster. And the question becomes sharper. When a method can be repeated across a wider world, who gets to shape it, and who gets to read it? Next, Gutenberg, the modularization of language.